Hello students, today I am going to talk about lumped system analysis. This context is particularly related to heat transfer mechanisms and especially related to unsteady state heat transfer mechanisms. Now let's first of all learn that what is an steady state heat transfer mechanism. Steady state heat transfer mechanism are those heat transfer processes in which heat transfer takes place through some system, but there is no temperature change of the system with respect to time. For example, suppose a metal rod is taken and from one end of metal rod heat is entering inside and from the other end heat is coming outside. Now in case the amount of heat which is going inside the metal rod is exactly equal to the amount of heat is coming out of the metal rod, in that case heat transfer, however heat is transferring through the rod, but there is no as such accumulation of heat with the rod. Suppose 10 joule is going per second and 10 joule is coming out per second, it means the net accumulation of heat inside the rod is 0. The balance is 0. So the temperature of the rod will not change with respect to time at any point. Rod is made up of many points, so at any point there will be no change of temperature with respect to time. So such type of heat transfer mechanism is steady state heat transfer mechanism. But unsteady state is that one in which there is rate of change of temperature with respect to time. For example, suppose we are taking a hot tea in a cup and we keep it in surrounding. Now eventually we will find the temperature of the hot tea will decrease. So there is rate of change of temperature in this heat transfer mechanism, means with respect to time the temperature of hot tea is decreasing, so it is having change of temperature with respect to time. Therefore it is an unsteady state heat transfer mechanism. Now unsteady state heat transfer mechanism itself is composed of its two subcategories. Those are lumped system heat transfer mechanisms and non-lumped system heat transfer mechanisms. Means unsteady state heat transfer itself is composed of two subcategories. So one is that one subcategory is the lumped system unsteady state heat transfer mechanism. Now what is lumped system heat transfer mechanism? See, for this we have to do an experiment. Take a watermelon, keep it inside the fridge. Now close the door for half an hour or 45 minutes. Now after then take out the watermelon, cut it into half. By the help of thermometer, find out the temperature of watermelon over its various points. You can see that the watermelon is cut into half, and by the help of thermometer the temperature is measured over its various points, over its peripheral surface, over its center and over other points. Now you will be surprised to find this thing, that at various points of watermelon the temperature is different. You will find this thing. What might be the reason behind this? See, when watermelon is kept inside the fridge, then it is inside a cold environment, so watermelon is losing heat to the surrounding. It is like this. Now when it is losing heat to the surrounding, then why at different points there is different temperature? Means when watermelon is taken out and cut into half, and in case temperature is measured at different points, then however the temperature is cooled down, you will find the temperature is less as compared to that of initial temperature, but at different point the temperature is different. Means you will find that over the peripheral surface the temperature is lower as compared to that of central point. So what is the reason behind this? The reason is that over the peripheral surface the grains of watermelon are more closer to the immediate cold surrounding as compared to that of the grains which are exactly over the center or around the center. So from center to periphery, see what happens, the peripheral molecules are just immediately releasing their heat to the cold surrounding, but the molecules which are over the center, first of all the heat has to travel through the solid material particles of watermelon, then it reaches the periphery, then it is lost to the surrounding. So for central molecule there is a thermal resistance more, that is the thermal resistance is due to the material of the watermelon itself. So conclusion is that the peripheral molecules are closer to the cold surrounding, so they are losing their heat fastly. So the peripheral molecules are more cooler as compared to that of the molecules or the grains which are over the center of watermelon, because from the center first of all the heat has to travel to the periphery. So there is one thermal resistance more, that is due to the material of the watermelon itself. So the center molecules cools down slower as compared to that of the molecules or the grains which are just over the periphery of the watermelon. So now, in this case there is rate of change of temperature, but we can see that at different points the rate of change of temperature is different. At periphery the rate of change of temperature is higher as compared to that of over the center. So such type of systems in which there is rate of change of temperature with respect to time, but at different points the rate of change of temperature is different, doesn't comes under the category of lumped system. So remember, learn this thing, that in case there is rate of change of temperature of any system, it is losing heat or gaining heat, but the rate of change of temperature is different at various points, then such type of system is not under the category of lumped system. Now one more example. So in the same refrigerator, take some water in a bowl, keep it inside the refrigerator and close the door. After 45 minutes take out the water bowl containing water. Now by the help of thermometer measure the temperature at various points. You will find that all where the temperature is same, the temperature is cooled down, but it is not like that of watermelon that at different points the temperature is different. So all where the temperature is same, all the molecules of water is having same temperature. So in this case there is rate of change of temperature with respect to time, means water is cooling down, so there is rate of change of temperature, but the rate of change of temperature at all points of system is same. Everywhere the decrement of temperature with respect to time is same. So such type of systems, it is an example, there can be many more examples, but it is an example. So such type of systems in which the rate of change of temperature, heat transfer takes place, but rate of change of temperature with respect to time remains same at various points, comes under the category of lumped system. So now we are having the definition. What is a lumped system? Lumped system is that unsteady state heat transfer mechanism in which inside the system the rate of change of temperature at all the points is same. So now we have the definition with us. Now what is the reason? So let's talk about the reason also, that what is the reason that in case we are keeping the water in a bowl inside the refrigerator and then taking out, then over all the points the cooling, over all the points the temperature, water is cooled down, but at every point the rate of cooling is same. The reason is that water is a fluid, so the molecules are in random motion. So wherever there is some hot molecule or some cold molecule, since they are in regular interaction with each other, since all the molecules are moving in zigzag fashion, so in case somewhere there is hot molecule and somewhere there is cold molecule, so cold and hot molecules are in regular interaction with each other, so they are, the hot molecules are giving up their heat to cold molecules, and thermal equilibrium is thus maintained, all where the thermal equilibrium is maintained. Now which parameters tells this thing that the system is under lumped category or not? There must be some parameter, because it is not a matter of feeling that for example we are not going to take any thermometer and again measure this thing that it is a lumped system or not. So there must be some mathematical parameter which tells that this particular system is under the category of lumped system or not. So that parameter is a non-dimensional number called as Biot number. Biot number's formula is given by Bi equals to HV upon Ka. Here H is the convective heat transfer coefficient. I think you might be knowing that what is the convective heat transfer coefficient. V is the volume of object. A is the peripheral area through which heat is transferring to the surrounding. and K is the thermal conductivity of material. So HV by Ka must be smaller than 0.1. In case for any system the H into V upon K into A is smaller than 0.1, then the system is taken as lump system, otherwise not. Then why it is? So let's discuss about this thing, that why this thing tells that it is a lump system. See, in HV by Ka, the unit of volume is L cube, we know this thing, and unit of area is L square. So V by A is having its dimension L. So we, in place of this HV by K, we can also write HL by K, because V by A can be written as L. Now this can be written as further, you can see L by Ka upon 1 by Ha. We can reform this HL by K like this, L by Ka upon 1 by Ha. Now L by Ka is the thermal resistance due to conduction, we know this thing, and 1 by Ha is thermal resistance due to convection. Got it? So it means that in case thermal resistance due to conduction is less than equal to 0.1 times the thermal resistance due to convection, then the system can be considered in lumped category. What does it mean? Let's talk about that also. See, consider this spherical system. Suppose there is a spherical ball. Now what happens in case we consider the central molecule of this system? Now from the center to the periphery, which resistance will act? Which thermal resistance will act? The thermal, because from center to the periphery the heat has to transfer via conduction. Therefore from center to the periphery the conductive resistance will be in the scene. But when it reaches the periphery, now it is losing heat to the surrounding. So over there the resistance is convective resistance. In case the convective resistance is more as compared to that of conductive resistance, then the system is more toward the side of lumped system. How? It means this, that over the periphery the heat transfer rate to the surrounding is less as compared to that of heat transfer rate from center to the periphery, because the conductive resistance is less, and in case it is sufficiently less, that is 10 times less than the convective resistance, so definitely the heat communication from center to the periphery will be fast as compared to that of heat communication from the periphery to the surrounding. So in such case the temperature, the rate of change of temperature with respect to time of the entire system will be same everywhere, and system can be considered fairly well inside the lumped system. So we conclude that in case the conductive resistance of the system is 10 times lesser than the convective resistance of the system, then the system can be taken as in lumped system category, like this. Now let's talk about that which kinds of system, practically which kinds of system can be taken as under the category of lumped system. In case a hot steel ball is kept in surrounding for cooling, then it is under the category of lumped system. The reason is that in case the size of ball is small, then first of all HV by K of the ball will come out 0.1. First thing is this. Secondly, we can think this thing, that since the ball is small, so from center to periphery the distance is small. So heat has to conduct through the material particles of the steel ball, yet the distance is small. So the rate of change of temperature from center to periphery will almost be same, because center is very closer to the periphery from where heat is ultimately lost to the surrounding. Similarly, a thin metallic sheet, suppose a thin metallic sheet is there and we are dipping it inside hot water. Then since it is thin metallic sheet, so the central plane, the molecules of sheet which are over the central plane are closer to the surrounding. So in this case also we can take it as a lump system. Similarly, in case a liquid is made too hot in some container by keeping it in hot surrounding, it can also be taken as lump system, because what happens that however the amount of liquid is more, but since the molecules of liquid are in continuous motion, they are in continuous motion. So heat transfer takes place due to two things. One is heat itself is transferring, as well as hot molecules and cold molecules are interconnecting with each other. They are interacting with each other. So heat transfer mechanism is almost same for all the molecules, because in case somewhere there is hot molecule and somewhere there is cold molecule, so since molecules are in random motion, so eventually they interconnect with each other, they interact with each other, and hot molecule loses its heat to cold molecule, and ultimately, like this, everywhere this thing is happening inside the liquid system. So a thermal equilibrium is established everywhere. So in case liquid is heated in a container, can be taken as a lumped system. Now let's do some mathematical analysis with lumped system. Suppose there is a ball which is hot and it is losing heat to the surrounding, and Biot number is less than 0.1, so we can take it as a lumped system. So over here we can see that the red color hot ball is kept in surrounding. Initial temperature is T1, surrounding temperature is Ts. So when it loses heat to the surrounding, ultimately it loses heat, and at the end it will become in thermal equilibrium with the surrounding, because heat transfer takes place from hot body to cold body. So the hot ball will cool down by losing its heat, but heat transfer rate will cease to happen once the hot ball becomes in with equal temperature with the surrounding temperature. So like this, the experiment is a hot ball is kept in surrounding, and suppose it is a lump system because Biot number is less than 0.1, and by losing heat it is cooling down, ultimately becomes in thermal equilibrium with the surrounding. Now suppose we are starting from time equals to 0. Now after some time, suppose the temperature of ball is T, capital T. When some time is elapsed, then the temperature of ball is T. So at that time, the heat transfer rate of ball to the surrounding will be what? We know that is HA dt. So HA, the temperature of ball, T minus Ts. Now this is the heat transfer rate at that particular time T. Now what would be the total amount of heat lost by ball at that time T in very small time duration dt? Since it is heat transfer rate formula, so we have to multiply it with very small time interval dt to get the amount of heat which is lost by the ball. So therefore the amount of heat which is lost by the ball is this much, that is HA T minus Ts into dt. Now this much heat is lost by the ball. Therefore what is the energy balance? See, this much heat is lost. Therefore this must be equals to minus ms dt. Here m is the mass of ball, s is the specific heat, and dt is the change in temperature, because heat is lost. We know this thing, that heat given to the system is ms dt, and heat taken out from the system is minus ms dt, because heat taken out it is taken as negative and heat given is taken as positive. So definitely, since heat, the amount of heat in a small time interval dt at time t is HA T minus Ts into dt, must be equals to minus ms dt. Now further we can do this mathematical operation, that is we can arrange like this: minus HA over ms into d small t must be equals to dt over t minus ts. Now integrating both the sides, since it is integration without limits, so therefore we will get minus HA small t upon ms must be equals to log t minus ts plus c. Now how to find the value of c? It's simple, by the boundary conditions. When time is 0 means when the experiment was just started, in that case the time is 0. So when time t small t is 0, then the temperature of ball is what? T1, that is initial temperature. So keeping the value time equals to 0 and capital T equals to T1, we are getting c equals to minus log T1 minus Ts. So keeping the value of c in the equation 1, we can see over the top there is equation 1. We are getting log T minus Ts minus log T1 minus Ts equals to minus HAT upon ms. So we know that log A minus log B equals to log A by B. So log T minus Ts upon T1 minus Ts is equals to minus HAT upon ms. And further, by removing log over the LHS, T minus Ts upon T1 minus Ts is equals to e to the power minus HAT upon ms. So what this equation is telling? This equation is telling that at time t, small t, what would be the temperature of the cooling ball in the surrounding? And the temperature, see, T1 is the initial temperature and Ts is the surrounding temperature. This capital T, only capital T is the variable which is telling that at time t, at time small t, what would be the temperature of ball when a hot ball is cooling in the surrounding and when it is taken in lumped category. So remember, this formula is applicable for all lumped systems. This formula is called as temperature profile with time formula for the cases of lumped system. Thank you.